In this program, we'll turn on a row of LED lights and then turn them off in reverse order. In the void setup function, use 6 pin mode functions to set ports 2 through 7 as outputs. This can be 3 single color LEDs and 1 RGB LED, or you can use 2 RGB LEDs. Within the void loop, we first see a for loop. The for loop has 4 key parts. First, you create a variable and give it a starting value. Next, you create a condition that checks the value of that variable. Third, you define a change to the variable that happens after the code between the curly braces runs. And fourth, between the curly braces is the code that runs whenever the condition of the for loop is true. In this case, we're creating an integer or int variable, and that means it can only be a whole number. Its name is I, which is a really common name for a counter variable within a for loop. And after a single equal sign, I'll give it a starting value of 2. That's because we're starting with port 2 as our lowest port on MakerBoard, so I want our for loop to start counting at 2. The condition here checks if I is less than 8. And if it is, the code between the curly braces will run, and then I++ will add 1 to the value of the I variable. Inside the curly braces, there's a digital write function with the arguments I and high. The first argument of a digital write function defines which port we're digital writing to. In the past, we've used numbers here. Now we're going to use the I variable, which we know is going to change the more times the for loop runs. So we're taking the I LED and setting it high, or turning it on. Next we have a delay function of 500 milliseconds. Before the first for loop ends, I is increased by 1, and the condition is checked again. After the first for loop is complete, the code is going to drop to the next for loop on line 21 here. This for loop has 4 parts as well. An integer I with a starting value of 7, a condition that checks if I is greater than 1, a change to the variable, which here is I minus minus, meaning subtract 1 from I, and code between the curly braces that runs when the condition is true. It's important to remember that this I variable on line 21 is completely separate from the I variable on line 15. When you create a variable inside the parentheses of a for loop, it exists only for that for loop to use. Now let's look at how this void loop is going to run when you have your LEDs plugged in. The integer I starts with a value of 2, and 2 is less than 8. So the code between the curly braces of the first for loop is going to use 2 as the port value in the digital write, and it's going to turn on port 2, turning on that LED. After a delay of 500 milliseconds, the first for loop ends, and it adds 1 to the value of the I variable. I is now 3. When the condition is checked, 3 is less than 8, so the condition is true, and the digital write function turns on port 3, turning on that LED. Another delay of 500 milliseconds, or 1/2 of 1 second, and the for loop reaches its closing curly brace, so I increases from 3 to 4, and the condition is checked again. Once I reaches a value of 7, the digital write function will write the port 7 high, and it will delay 500 milliseconds, half a second, before reaching the closing curly brace of the for loop and adding 1 to I. Now I will move from 7 to 8. 8 is not less than 8, so the code between the curly braces will be skipped, and the program is going to move down to line 21. At this point, all of your LED lights are turned on. For the second for loop, we have an integer I that is equal to 7, and as long as I is greater than 1, we'll run the code between the curly braces. 7 is greater than 1, so the condition is true, and the digital write function will write port 7 low, turning off the LED plugged in there. After a delay of 500 milliseconds, the program reaches the closing curly brace of the for loop and runs I minus minus, subtracting 1 from the value of I. Now I equals 6. The condition is checked and 6 is still greater than 1, so the code between the curly braces runs digital writing port 6 low, turning off that LED. Another delay of 500 milliseconds, and the program reaches the closing curly brace of the for loop and subtracts 1 from I again. Eventually, I will reach the value of 2, so we will digital write port 2 low, delay 500 milliseconds, and then subtract 1 from the value of I. I will move from a value of 2 to a value of 1. 1 is not greater than 1, so the condition of the for loop is no longer true. The code between the curly braces will be skipped, and then this for loop will be complete. Then the program will reach the closing curly brace of the void loop on line 25. It will jump back up to line 15 and start again, creating a variable with a value of 2, checking if 2 is less than 8, and turning on the LEDs. So this for loop on lines 15 through 18 is going to run 6 times. Then this for loop on lines 21 through 24 is going to run 6 times before the void loop ever starts itself over again.